Hi, how you doing, guys? Today we're going to have a lesson on friction. Recall that there's two ways to solve friction. One is using F net equals ma, and the other formula is frictional force is equal to mu times the normal force. Recall that mu is the coefficient of friction. So the product of the coefficient of friction times the normal force will give you your frictional force in newtons. So first of all, we're going to start with how to solve the frictional force without ever using this formula. So we're going to start by using F net equals ma. So we're going to come up with our first question here. And it's going to be right here. Question number 7. So I'm just going to expand this up so you can see it. But question number 7 says, a 50 Newton horizontal force is needed to keep an object weighing 500 newtons moving at a constant velocity of 2 meters per second across a horizontal surface. What is the magnitude of the frictional force? Okay, so first of all, we're going to start by drawing a diagram and a free body diagram. Recall that when we draw a free body diagram, you draw your x and your y axis, okay? This is mass m. The downward force is F sub g equals mg, that's the weight. We know that it's balanced by the normal force, F sub n, okay? And then we could also draw the block. Now when they say 500 Newton block, that's the weight of the block. So 500 newtons, that's the weight. We're applying a force of 50 newtons horizontally. So let's say the force is going to the right. 50 newtons, we're going to call that FA for force applied. And then we could draw it on our free body diagram, FA, and that equals 50 newtons. Okay? It's also moving at a constant velocity of 2 meters per second. Okay? So recall that constant velocity means that the acceleration is 0. When you're moving in a straight line at a constant speed, also known as constant velocity, your acceleration is 0. So when we look at this formula, if your acceleration is 0, whatever the mass is, your F net has to be 0, okay, to satisfy this equation. So 0 equals 0. So if the forces, F net is 0, we know that the forces are balanced. We already know that the normal is balanced with the weight, but the right applied force of 50 newtons must equal the frictional force, which is opposing the motion. Your frictional force, therefore, is 50 newtons. So here's one example of where we were able to determine the friction just using Newton's second law. In this case, the object is moving at a constant velocity. Okay. Next order of business is we're going to use this method to solve a problem where you're accelerating. Okay. So let's take a look at the another situation here. So we're going to look up on this PowerPoint here, and you'll see that the next question is this. So we have a situation where a block is accelerating to the right at 10 meters per second squared. It's a 4 kilogram block. We're applying a force of 50 newtons to the right. Our friction's to the left. We want to know what our friction is. Again, we're going to use Newton's second law. Okay? So how do we do that? Well, first of all, we should first write the direction of the F net. We know that F net, or you should recall that the net force and the acceleration always point in the same direction. So we know that the F net is this way. That's the net force. We can get the net force by taking the product of mass and acceleration. We know that the mass, it's a 4 kilogram block, and we know the acceleration is 10 meters per second squared. So we're going to multiply them out and we get 40 newtons. That's F net, okay? So now we know that if we have an F net to the right of 40 newtons, that equals the sum of the forces. So that equals F net is equal to your applied force plus your frictional force. We know F net is moving to the right. That's a positive 40. Your force applied is a positive 50. So we can figure out what our frictional force is. Okay? Frictional force, we're going to subtract 50 newtons from both sides, and you're going to get negative 10 newtons is your frictional force. And that should make sense. Our frictional force is 10 newtons to the left. Okay? Then we're going to check our work. If I have a force vector going to the right and I subtract my friction, 50 minus 10, will that give me 40 to the right? And the answer is yes. Okay, next order of business, we're going to talk about the second method to quantify friction. That's called, we're going to use the formula, the coefficient of friction times the normal force. So let's do a couple problems here. First, recall that we have to consult a table called the coefficients of friction. The coefficients of friction are right here on your reference tables, on the front page of your reference tables. There's two columns of coefficients of friction, kinetic and static. Okay? So recall that the coefficient of friction is really related to the roughness of the surfaces in contact. Now I know that like wax ski on snow, that's a very smooth surface. And when we see wax ski on snow, it's no surprise that they're very low coefficient values because they have a low roughness factor. If we have rubber on dry concrete, that's high amount of friction. Okay? So sure enough, the coefficient of friction is a very high value. So what we're going to do now is we're going to consult this graph right here. This graph shows that the frictional force keeps building every time we try to move an object, and it peaks out at a maximum friction called your frictional force maximum static friction value. Once the object starts to move, it immediately drops down to a lower value. That's the friction while the object is moving. Okay? So let's come up with a simple scenario here. We're going to take a steel block on a steel surface. Okay? And we're going to make the block 10 kilograms. So what is the minimum force I need to move this block? Okay? Well, what we have to do is we have to use our formula here. We know the surfaces is steel on steel, so we're going to say that the frictional force static is mu s Fn. We're going to draw a free body diagram, and you should know, right, drawing your xy axis, that we have F sub g equals mg down in the y direction. The normal is going up. So we know that the sum of the forces in the y has to be 0. So we know that our normal magnitude has to equal the weight. Okay? So what is the weight? Well, we know that F sub g equals mg. So we know that the mass is 10 kilograms times 9.81 meters per second squared. That comes out to be 98 newtons. So our normal force must be 98 newtons to balance. Okay? The normal force is very important because we need that to quantify our friction. So we're going to first use the coefficient of static friction steel on steel. When we look at the value steel on steel, the static column, we see that it is 0.74. So we're going to plug that in. The frictional force static max is 0.74. Notice there are no units for the coefficient of friction, for any coefficient of friction, and the normal force is 98. So we're going to take 0.74 times 98, and we get 73 newtons. Okay? Now we're going to take our frictional force kinetic and put the kinetic value in times the normal force. Well, the kinetic value, if you look, steel on steel, is a 0.57 times 98 newtons. So when we take 98 newtons times 0.57, I get 56 newtons. Okay? So what are we going to do with these two values? Well, we know that the object isn't going to move until we apply a minimum of 73. So what we do is we look at this chart. The maximum friction you're ever going to encounter in this given situation is 73 newtons. Okay? Once the object is in motion, all you need, your friction is mu kFn, which we established was 56 newtons. Okay, I'll write that value in here. So you need to reach this point up here for the object to move. So what happens if you don't have enough to move it? Well, your frictional force is always going to be equal to your applied force. For instance, if this is 10 newtons, if I apply 10 newtons on the block, right, the frictional force will be 10 newtons, because that's Newton's third law. So let's draw a block over here. If I try to move this block with 10 newtons, we know it's at rest because we need a minimum of 73 newtons to move it. So my frictional force is going to be 10 newtons, right? If I apply 30 newtons, my frictional force will be 30 newtons because it's still not enough to move it. Finally, if I apply 73 newtons, that's the slipping point. It's just about to slip, and it's going to be ready to begin to move. So if we apply more than 73, just a hair over 73, the block will begin to slip. Okay? So say I apply 80 newtons. Well, what happens is we know that the block is going to move, so therefore my friction, since it's moving, will be only 56 newtons. So my friction is now 56 newtons. It's not going to match me anymore. As long as that block is moving, the friction, whatever I apply, as long as it's moving, my friction will stay at 56. So I could get my F net now. I could take 80 minus 56, and I know this object will accelerate. Okay? One more thing is, what if we want to calculate the coefficient of friction in a situation? Well, we know that the coefficient of friction is this. Okay? So say I have a block resting on a surface and it's moving to the right, right? Let's make up a speed here, 10 meters per second. And I'm applying a force of 30 newtons. The block has a mass of 2 kilograms. Okay? So what is the, and it's a constant speed. So what is the coefficient of friction? Well, the coefficient of friction, divide both sides by Fn. We know that the coefficient of friction is the frictional force divided by the normal force. Well, we can easily get the normal force. We know that the downward force is the weight, mg. We're going to take 2 kilograms times 9.81 meters per second squared. We know that the weight is 19.62 newtons. So we know that the normal must be 19.62 newtons. So how do we get the coefficient of friction without knowing the surfaces in contact, right? Because we didn't make any mention of the surfaces. Well, to get your coefficient, you need your friction, which we know now. It's moving at a constant speed. F net is 0. So our applied force is 30. So our friction must be 30. Right? We're using Newton's second law. The acceleration is 0. So therefore F net is 0. Okay? Now that we know our friction is 30, we're going to plug it in here, 30 newtons. Now we need to get our normal force, which we already know is 19.62. Notice that the newtons cancel out. That makes perfect sense because we know the coefficient of friction has no units. So finally, we're just going to divide it out. 30 divided by 19.62. we get 1.52 for the coefficient of friction. Okay, so that's how you would get the coefficient of friction. I just made up this problem. The coefficient of friction is normally under 1. So you're always going to get a value under 1. I just want to point that out to you. But that's how you get it. You need these two things, your frictional force and your normal force, to get the coefficient of friction. Thanks a lot for watching.